Welcome everyone to our academic webinar today. I don't want to steal a lot of time because it's a new topic, teaching consumer research methods, Conjoint, Discrete choice, and MaxDiff. And I'm excited to introduce you to my colleague, academic ambassador Ross Methusalem, who is located in the United States and will be the presenter today. I've just one request. You are welcome to send us any questions you may have or comments, and you really help us if you use the Zoom Q&A panel to send your questions, and we will try our best to answer them either during the session or later on. And with this, Ross, it's your turn.
Great, thanks, Volker. Appreciate you being here to host and answer some questions in the Q&A as we go along. Everybody, thanks for joining to talk about teaching consumer research methods with JMP. As Volker mentioned, this is actually a new topic for us in the JMP Academic webinar series, so we're looking forward to providing some new information and maybe engaging with some new folks out there. Consumer research methods is a really broad domain. So I want to emphasize that today's focus really is on specific methods for studying consumer preferences or choices. So that is what's defining the scope of today's webinar. JMP's consumer research methods are not limited to Conjoint, Discrete choice, and MaxDiff, though. So I wanted to begin just very briefly by talking to you about JMP's consumer research capabilities to give you an idea of the coverage. So if you go to the Analyze menu in JMP, and I should mention I'm right now in JMP Pro 18. Under the Analyze menu, you're going to find Consumer Research as a submenu near the bottom. We're going to cover the Choice and MaxDiff analysis platforms today. You'll notice there are a few others listed here. So the categorical platform is really made for survey analysis. It's a robust cross-tabulation tool. We also have uplift modeling and then multiple factor analysis, which is for the analysis of sensory panel data. These tools live under the consumer research submenu because they really are specialized tools that are going to be applicable almost exclusively, though perhaps not exclusively, to consumer researchers. But there are many additional tools under the Analyze menu, not under the Consumer Research submenu. So to highlight a few, if you are teaching market segmentation, don't miss the clustering menu. Perhaps you're teaching predictive analytics or predictive modeling, in which case you might be looking for the predictive modeling menu. Text Explorer is a general purpose text mining tool. We also have some more specialized tools. Let's say you're teaching time series and forecasting. We have tools in the specialized modeling menu for that. Maybe you're teaching multivariate methods like structural equation modeling, factor analysis, or multidimensional scaling. Or maybe you're even teaching modeling customer churn, in which case you might be interested in our reliability and survival list, in particular down here, survival and parametric survival models, things of that nature. So a lot of different tools under the Analyze menu to employ a wide range of consumer research methods. Also, we're going to see a couple tools today under the DOE or Design of Experiments submenu. You'll notice a Consumer Studies submenu here where we have tools for designing choice and MaxDiff experiments. We're actually going to see another DOE tool today in the context of the design of our Conjoint study. So if you teach consumer research methods, again, I just don't want you to leave with the impression that all we have here at JMP is Conjoint, Discrete choice, and MaxDiff. There's a really broad coverage of applicable capabilities here. All right, so let's leave that aside, though, and again, focus on these methods specifically for studying consumer preferences or choices. And we're going to start with ratings-based conjoint analysis. And before I actually open this section of my JMP journal, and I should mention you'll all get a link to this journal and to the recording of this webinar. I do just want to define what I mean by conjoint here, and I've attempted to do that by using the term ratings-based conjoint. So that's a type of study in which we present product profiles consisting of multiple attributes one at a time to each respondent, and that respondent provides a rating. Maybe it's an intent to purchase, maybe it's based on something else, oftentimes on, say, a 1 to 10 scale, and then we analyze those ratings. I'm bringing this up because the term conjoint can be used more broadly. I've encountered it to refer to all kinds of different methods that involve studying conjoined product attributes and preferences or choices with respect to them. We're specifically talking about ratings-based conjoint analysis here. So I'm going to lead with this example data set. This is from a designed experiment eliciting preference ratings for different musical instruments, specifically flutes of different profiles, where the flute might be made of a different material using a different method and be priced at one of 3 values here. We are going to take a look at how to perform conjoint analysis on this data. We'll also see how to design the experiment behind this up front. Just to give you an idea of where we're going, here is the output we're going to produce, where we have, among other things, a table of part worth values right here for each level of our 3 attributes. And we also have an interactive profiler that we can use to, for any product profile, calculate the utility. So for example, right here, a plastic flute made with a hybrid of hand and machine methods, priced at 100 USD, has a utility of 6.58 approximately. And if we change that to a bamboo material, that utility goes up to 7.71. This example is from our case study library. So let me click on this link to get to the case study. So again, you'll get this journal and you can use all the links that I'll show you today. If you're not familiar with the case study library at JMP, which you can find at jmp.com/cases, it's a collection of real-world data analysis problems with multi-step solution paths and exercises for students to do. Each one comes with a document and the relevant data sets. So we're looking right now at the pricing musical instrument case study, and I can find the PDF by clicking download case study right here. So in our case study, we imagine that somebody is manufacturing and selling musical instruments, including flutes, and the perceived quality of the flute depends on the method that it was made, and also the material, and that there are 3 potential price levels. So once again, corresponding to those 3 different attributes we just saw in the data table. So we're going to do a ratings-based conjoint study. We'll design the study as we see here in Exhibit 1 in this case study. Then we will perform the analysis using JMP's fit model platform. We'll get these part worths out, calculate relative importances for each attribute, and use the profiler to calculate those utilities. So this is, again, the pricing musical instrument case study in the case study library. So this is the data set. Let's actually back up and talk about how to create the design for a ratings-based conjoint study like this. So we have 3 levels of material, 3 levels of method, and 3 levels of price. So 3 to the 3rd is 27. If we were to use a full factorial design, probably the most basic study design that we might be familiar with in consumer research or really in any other domain, those 27 different product profiles would probably be a bit too many to ask your average respondent to rate, or at least rate reliably. So what we're going to do is use a DOE platform in JMP to create a fractional factorial design to get this down to 9 runs. If you look right here, we have respondent ID in the first column. Here, all the rows corresponding to respondent number 1s. You can see there are 9 profiles that they rated in total. And if you look, these are balanced across all 3 levels of each of our attributes here. So each one appears equally often. So let's create this design, and then we'll come back and do the analysis. So to create the design, you may want to go to the DOE menu and find the classical submenu, which will give you tools for creating both full and fractional factorial designs, or go to the custom designer at the top if you're familiar with modern optimal design and want to use that approach instead. And I should mention, as I'm describing some of these things, I realize I'm going over some of the details, so if you're not too familiar with experimental design, there's plenty of other materials at jmp.com or at the JMP user community, community.jmp.com, to learn about some of these methods. Given that this is a teaching-focused webinar, I assume you have some degree of familiarity with the methods, and so we're not going to go too deep into some of the details, instead focused on the different tools to use and how to use them in a classroom context. Okay, so with that caveat, let's go down to the classical submenu, where we can find full factorial designs right here. And under factor screening, we can find screening design, which is going to help us produce a fractional factorial design. So that is a subset of the 27 total possible product profiles. So we'll pull up our screening design. Here's what the JMP DOE window looks like. I can double click where it says responses here and just type in the name. So that's where people will provide their ratings. And then where it says factors is where I will enter the product attributes. So let's say, for example, I wanted to add a 3-level categorical factor, and that was the material of the flute, and that could have been bamboo, let's see, metal, or plastic. And then I could, of course, add another 3-level factor for the method and another for the price. I also, instead, could start with a table of the attributes that I want to include in the design. The DOE platforms can actually create the proper table for you using the Save Factors option under the red triangle menu here. So go ahead, specify your attributes and their levels, and then create this table with Save Factors. And what that allows you to do, especially in a teaching context, is make this a little more foolproof when your students are specifying the design up front. You can see I have a column here that says material with our 3 materials, 3 methods, 3 prices. And now I'll just go to the red triangle and choose load factors. And now I know that all of those have been brought in correctly. All right, so we have our factors. Now let's click continue. We can choose from a list of fractional factorial designs or create a main effect screening design. In the case study that I referred you to, we choose this Taguchi design right here. So I'll click continue and make table. And now we have the design table itself. So here are the 9 product profiles that we'll present. We can copy this for each one of the respondents. We actually don't need this pattern column, so we'll get rid of it. But this is how you create the design. It's pretty straightforward, especially for your students if you provide that attribute table. It's just a few steps to be able to create one of these. All right, so we've created the design. Let's get back to the data set, look at how to actually perform a ratings-based conjoint analysis, and get some tips for using it with your students. So let's get back to our data here. When you create a experimental design in JMP, the table that you get out will include a script that says model. And if you click the green arrow next to that, it will actually launch the appropriate analysis tool. In this case, it's JMP's Fit Model platform, which is a general purpose linear regression tool. And you can see that it even has the dialogue filled in for me. However, if you are using a data set that you've gotten elsewhere, you won't have this script necessarily. If you've imported it into JMP from, let's say, an Excel file or a CSV, maybe from a textbook. So I'll show you how to set this up manually. So we go to Analyze, Fit Model. Okay, let's say that it wasn't filled in. You take your rating variable, put it in the Y role up here, take your product attributes and click Add to add main effects down here. If you are going to include cross terms, so that is interactions, you can use the cross button to add them. But in this example, it's just a simple main effects analysis. I recommend setting emphasis to minimum report, which is going to give you the simplest output, and then click Run. So let's get rid of our data table for now and just have a look at this output. Fit Model is a general purpose linear regression tool. Ratings-based conjoint is really just a regression model, but there are some things that we want to do, or specifically information we want to find in this report that corresponds to the things we most care about specifically with respect to conjoint. So I'm going to close up all of these default tables and then open up the parameter estimates where you're going to find the part worth values. So here you can see them right here. Now, it's time here for a quick aside on how JMP codes categorical factors like these product attributes that we have here, because if you're familiar with categorical factors and regression models, you know that there are multiple ways to code them. So you'll find a little note in the journal that you can refer to later right here. Just know that Fit Model by default is using effects coding. So that's where the estimates all sum to 0 and the intercept represents the grand mean. And this is a common coding scheme used in conjoint analysis. Of course, when you use effects coding, there is an omitted level. That level is the final level in the value order property in your JMP data table. So you can right click and go to column info and set a value order property. By default, it's alphabetic. So what you're going to notice right here is we only have 2 part worths listed, one for bamboo, one for metal. There is none for that final attribute level plastic. And that's because this is automatically determined by the values of the first 2. Add 0.356 together with 0.422, multiply by -1, and you'll get the value of plastic. Now that, of course, I already would think for a lot of classes, I would not want my students to have to do that by hand, which is why I absolutely want to point you to the expanded estimates table that you can access under the red triangle. So go to the red triangle, and under estimates, you're going to find expanded estimates. And now you have the full part worth table right here. So you can see that we have the omitted levels here: plastic, the machine method, and the $150 USD price. So here's our full part worth information. Now there's a number of other potential outputs that we might want to explore here. One is the utility of each potential product profile. And to look at that, pull up JMP's profiler under the red triangle. So I'm going to go to factor profiling and choose profiler. If you're not familiar with the profiler in JMP, anytime you build a model, you have this interactive visual representation of the model that you can use to change the values of the inputs, in this case, our attributes, and see the corresponding output value from the model. In this case, it says rating. You can also call this our utility. So let's say that we wanted to find the profile with maximum utility. Given that this is a main effects model, I could just find the highest material, which is metal, method, which is hybrid, price in USD, which is 100, to find a utility of 7.78, versus, say, the lowest utility, which is a plastic handmade at 150, with the utility of just 3.91. So you can use the prediction profile to calculate those utilities. If you want the utility for every single possible profile, so 27 in all, go to the red triangle here and select Output Grid Table. What that's going to do, the grid means, in this case, every possible combination of attribute levels. So we have 27 in total. You have each one listed across these 3 columns, and then the final rating or utility value. I'm going to delete these others because we don't need them right now. One thing that's nice about this is that you can actually plot this to demonstrate the differences in utilities across different profiles, help students understand these values a little better. One thing I'm going to do is actually highlight all 3 of these attributes, right-click and go to New Formula column, and Character Concatenate with Space. That's going to give me a new profile column that just concatenates each attribute level, so we know the full profile. Let's actually just rename this profile. And then I can go to Graph and Graph Builder and just put, let's say, put the profile on the y-axis, a rating or utility on the x, select a bar chart, and then I'm going to right-click where I see the profiles and go order by rating ascending. And now I've plotted the utility of every product profile. I can see metal hybrid at 7.78, bamboo hybrid very close behind 7.71, until we get all the way back down to that plastic hand at 150, 3.91. So that's just a little tip for helping students maybe digest some of these utilities and think about all the profiles and the distribution of utilities across them. All right, let's get rid of that table and introduce just one more issue here. With rating-based conjoint, typically want to calculate attribute importances. So what's the relative importance of material over method, or method over price? So if we teach this, we know that what you do is you take the range of part worth values for each attribute. Then you take, for any attribute, its range divided by the sum of all ranges to get the relative importance. Now, you can do that by hand, and maybe in your course, at least at first, you want your students to do that by hand to understand where those values are coming from, but it can be cumbersome, and there's no red triangle option to produce that automatically in FitModel, because again, this is a general purpose tool. It's not built specifically for conjoint analysis. So one thing I've done, and I'll provide you with this file along with the journal, that'll be posted with the recording, is a JMP workflow that will perform the importance calculations for you and your students. Now, if you're not familiar with JMP's workflow builder, it's a tool, and you can find or launch a new workflow under File, New Workflow. It's a tool that can record your point-and-click steps, capture them as JMP scripting language, and then allow you to apply them to new data sets or new reports. And I've built one here that will, for the active fit model window with an expanded estimates table open, all you do is hit play, and it will produce a JMP table with the variable importances right here. And you can actually see next to this column, we have the range of part worths for each attribute, and then this formula is simply just the part worth range for the current attribute divided by the sum of all of those part worth ranges. So go ahead, use this workflow. You can always adjust it as you like with your students. If you need to make adjustments, I recommend clicking the red triangle, go to display options, and turn off presentation mode, which I have enabled by default to get into the full ability to edit the workflow. But just to give you an idea, behind the scenes, again, what it's doing is executing a number of steps in JMP scripting language that were largely captured by my point-and-click actions, just to calculate those importances for you. So hopefully that workflow is of use to you and closes a quick gap that there is in fit model when using it to teach conjoint analysis. So let's see, I'm going to take a quick look at the Q&A to make sure it looks clean before we carry on. It does. All right, wonderful. So let's move on now to talk about MaxDiff and discrete choice. So two methods underlyingly, based on random utility theory, where we actually have respondents make choices among multiple product profiles and use that information to determine the underlying utility of different profiles or product attributes. So let's go to MaxDiff and take a look at the example that we're going to do. This comes bundled with JMP, this example, so it's not in our case study library. This is the potato chip example, where we're doing a MaxDiff, or I should also say, if you're more familiar with the term best-worst scaling, same thing. We're doing a MaxDiff study on different flavors of chips. So for example, gyro or Southern barbecue or biscuits and gravy. And we're trying to determine consumer preferences for these different flavors before maybe introducing them to certain markets. You can see that in this particular study, we have a number of different respondents, 30 in all. You can see this respondent, Aaron, he completed survey number 1. So we actually have 4 different surveys that people completed. And they faced choice sets of size 2. So in each trial or run or question on the survey, they were presented with 2 flavors. In this case, they tasted each one. Oh, excuse me, not 2, 3. I'm getting myself confused here. So gyro, Southern barbecue, and biscuits and gravy in this first choice set. Then they mark the best or their preferred with a 1 and the least preferred with a -1, and all others, in this case just 1, receive a 0. And here's the analysis we're going to do. So this is using JMP's MaxDiff platform, where we calculate the marginal utility and probability for each of our 10 flavors. So it looks like barbecue comes out clearly ahead here, then Southern barbecue, and then it's from truffle fries down to gyro. People are not particularly fond of them. And under the red triangle, a few options, including the ability to do comparisons. So let's compare barbecue, in this case, to the least preferred gyro. And we create a table where we can see the utility for each flavor, the selection probabilities. So just between these 2 flavors, the probability of selecting barbecue is over 0.9. It's at nearly 0.92. We have the odds of those selections, also the difference in utility and the standard error of that difference. So that's where we're headed. But first, as we did with the last example, let's talk about how to design this study. I should also mention, if you want more information, this is a relatively simple example, so I didn't point you to a full document describing it, but I did provide a link down here to the JMP documentation that shows this example in slightly more detail. So anyway, let's talk about designing a MaxDiff study. To do that, we're going to go back to that Consumer Studies submenu under the DOE menu and choose MaxDiff Design. So let's do that. I'm going to go to Consumer Studies, MaxDiff. you'll notice actually that right off the bat, it provides a launch window. So this is unlike JMP's other DOE tools where you get a window that asks you to, say, type in your attributes and their levels. Here, it's actually looking for a table where you've already specified those attribute levels, and you put the column containing them here. So I actually launched this. I have a different table open. So this is actually, if I bring it back, I should have closed it instead of minimizing it. This is our instrument preference data, and that's not what we want to do. So let me cancel out of this. If you don't have any tables open, it'll actually prompt you to open a table, but let's open our profile table. So here we have our 10 different profiles. Each one is really just a different flavor of potato chip. We also have some information in this example that I'm not going to use here, and that's just whether it's a product of the US or Canada. So now I will go to DOE Consumer Studies, MaxDiff, put flavor in as my factor, and click OK. And now we have a pretty simple design window here. You'll notice that we have two values to set: the number of profiles, in this case flavors per choice set, and the total number of choice sets. And it's defaulted to 4 and 15. It's defaulted to values that correspond to a balanced incomplete block design, or BIBD design, if you're familiar with these. And here's some other BIBD design possibilities here. If you're not familiar with BIBD designs, let me click Make Design and tell you about them. So here is all of our choice sets, 1 through 15, each one consisting of 4 flavors. In a BIBD design, every possible pair of profiles occurs equally often across the choice sets. And this pairwise incidence matrix shows us that. So you can see on the diagonal, the value of 6. That's showing us that each flavor occurs in 6 of the choice sets. You'll see every other value off the diagonal is 2, showing us that each pair of flavors occurs in exactly 2 choice sets out of the total. So for example, this 2 shows us that barbecue chips and all dressed chips occur in 2 choice sets. So this is a desirable design in that we know that every direct comparison between flavors is made an equal number of times across the survey. But it doesn't have to be that way. So JMP defaults to a BIBD, but you can declare an arbitrary set number and size, and JMP will try to approximate a BIBD as closely as possible. So let's take a look at what that looks like. I'm going to go to Consumer Studies again and choose MaxDiff. Let's go ahead and click OK with our flavor. And now instead of going with the defaults here or any of the other balanced designs, I'm going to do what they did in the example in the documentation and say that we have 3 profiles per choice set and only 4 choice sets per individual. So given that this is a potato chip tasting, having a much smaller survey experience might be appropriate for these individuals. So they're going to do 12 total tastings. When I click Make Design, you can see it's a much smaller design. And in the pairwise incidence matrix, compared to the default above, you can see we have all dressed in barbecue chips occurring in 2 choice sets. Each other one only occurs in 1. And many of the pairs don't occur at all. So let's say biscuits and gravy does not occur with all dressed in any choice sets, but gyro does. So you can actually create designs apart from the traditional BIBDs. Also, you can create multiple designs, even with the same settings of size of choice set and number of choice sets, and get different designs out to create multiple surveys. And that's what was done in the example that we're doing right now. If you recall, when I went to the data table, we had 4 surveys in total. So 4 different surveys where, again, each choice set is of size 3, and we have 4 choice sets in total. All right, so that's a little bit about designing the MaxDiff studies. Now let's talk about analyzing them. So much like with other design tools, if you design the study in JMP, you're going to get this MaxDiff script out where you can click the green button and it will automatically run the analysis for you. But if you have a data set that you have imported and you don't have that script, here's how you specify it manually. So start by going to Analyze, Consumer Research, and MaxDiff. So we'll go down here and find our MaxDiff platform. This is a more complex launch dialog than many other platforms. So let me walk you through it and make a suggestion about the best way to use this with students. So here's our data format. I described it briefly. before, but to make it even more explicit, each option within a choice set gets its own row. So choice set number 1 here for Aaron has 3 rows. You have which flavor was shown, and then again, the response column has a 1 for the best, a -1 for the worst, and a 0 for everything else. Up at the top here, you're going to have response indicator, and you're going to want to put that response column with the 1s, 0s, and -1s in there. You need to have some kind of subject ID, that's respondent here. You need to have an ID about the choice set within the respondent, so it knows that these 3 rows belonged to the same choice set. So I'll put that as my choice set ID. And then down below is where you can put in the product profile to construct a profile effect. And maybe you have more than one. In this case, we just have flavor. And you can also, if you have subject side effects, put them in here. We don't have any in this particular example. Then we click Run Model, and we get to the model that we got when we just clicked this button. That said, as I mentioned here, there are actually single and multi-table formats that are supported in the MaxDiff platform. We're using single table, but just to give you an idea of what multi-table would look like, in multi-table, you have a profile table, much like the one we started with. And then you have a data format where each row corresponds to a choice set. So here's Aaron, survey 1, choice set ID. Here are the 3 choices that were presented in that choice set and the best and worst. And you'll notice that these are just unique identifiers, L1 through L10, corresponding to the profile ID right here. Now, setting this up is a bit more complex, and I'm going to show you this just to personally, and then this is my opinion, discourage you using this format with your students. So let's go back to MaxDiff, and at the top, I'm going to actually select multiple tables that are cross-referenced. So right off the bat, the first thing I need to do is specify my profile data. So that is this table here, potato chip profiles. So I need to say that that's what the correct table is. Provide the profile ID, that's that unique identifier. Provide our profile effects. In this case, I'm just going to do flavor. Then I need to specify our response data, which is this table where I've actually stored the responses. So let's select that. I'm going to go to potato chip responses. The best choice is here, worst here. Our profile ID choices is all 3 of these columns, choice 1, 2, and 3. Then we have a subject ID, that's our respondent down here. And then if we have subject side effects, we would pull those out of a 3rd table and link using a unique subject identifier. So if you're looking at this format and thinking, well, that was kind of a lot, I'm pretty sure my students would make mistakes filling out that dialogue. I personally feel the same way, which is why I think it's much better to stick with the 1 table format if you can. And I already showed you how to do the 1 table format, so let's get back to that model that we produced. So we have marginal utility values, scaled and summed to 0 right here. So again, we can see the utility for barbecue at 1.28 approximately versus the bottom gyro, -1.16. Under the parameter estimates, you're going to find a fuller table. So the estimates here correspond to those marginal utilities. You also get standard errors. And under the red triangle, go ahead and pull up the confidence intervals if you are interested in those as well. So that's the parameter estimate table, again, corresponding directly to our marginal utilities. But in the main results, we also get the marginal probability. So this is the probability of selecting each flavor if presented with all of the possibilities. So here's a point where I like to use a certain technique, at least I did in my own teaching, where sometimes showing how easy it is to derive some values, like these probabilities, from values that we already have, to help make it clear that, in this case, these marginal probabilities aren't being pulled out of thin air. It's actually using an equation that hopefully would be very familiar to students, even in a more applied course. So let's just take a look at how to do that. You can right-click in any jump report table and go into Make to Data Table. And now I have these values in a jump data table. I'm going to create a new column, right-click and go to Formula. And then I'm just going to put in the choice model formula that we can then use to calculate these probabilities. And so if you teach this, I hope this formula is familiar to you. We just take the constant E from our list down here. We raise it to a power of the utility estimate. And so this is for each row, we're going to find e to its utility. Then I'm going to divide that by the sum of all of these values, e to the utility. So what I need here is the call sum function, and then do the same thing, e to the marginal utility. So this right here should look much like a simple equation presented in even an applied textbook in this context. Hopefully would be familiar to students. If I click OK, and then let me just actually change to, let's say, fixed decimal format to match the output here. We'll move this next to our probabilities. You'll notice the values are identical. So sometimes, it's hard to translate from a textbook and the way that values are presented to the outputs of a statistical package. This is just one example of how sometimes you can do something just a little clever in JMP to show, hey, those values that you're seeing, those are calculated using a formula you already know that was probably introduced at the beginning of this section. That was just a quick aside, a little idea for classroom use there. Now, as I mentioned before, there are some additional tools here under the red triangle. For example, we could do profile comparisons. So before we did just a pairwise comparison between barbecue and gyro, let's actually now do barbecue versus any other flavor. And all those comparisons are added below. So again, we have the difference in utility values and the standard error. We have the selection probabilities for each choice right here, given the paired options, and the odds of each choice as well. So you can use this tool to calculate these values for any possible pairing for a choice. You also, if you're interested in all of them, can go to the all levels comparison report, where here we have a matrix of every possible comparison where we have the utility difference, the standard error, and a p-value. So if we look, for example, at barbecue, at those color-coded p-values down below, we only see one right here, Southern Barbecue, that has a p-value above 0.05. So it looks like maybe we don't have evidence that barbecue is actually preferred over Southern Barbecue here. Now, last thing to mention, and some of you may teach this, some of you may not, but certainly in practice, it's common to use MaxDiff or choice models to perform market segmentation so that ultimately you're not marketing products to the, quote, average consumer who doesn't actually exist. And there are a number of ways you can do that here depending on your preferences. So I'm just highlighting that there are multiple options. You can click this link to go to the relevant part of the documentation to see what those options are. But I want to show you just one way to give you an idea of how all of this works. So I'm going to stick with our data table right here. I'm going to go back to our consumer research and MaxDiff. Let's fill out our dialog as we had before. So here's our response indicator, our subject ID, our choice set ID, our flavor. Now, if you have JMP Pro or the JMP Student Edition, you can tick this option, hierarchical Bayes. I should mention, actually, now that I mentioned the JMP Student Edition, if you're not familiar, the JMP Student Edition is a new product that brings all of the advanced analytical capabilities of JMP Pro free for academic use. So that's academic research or teaching. You and your students can just go to jmp.com/student to get started with that. So anyone who's teaching this at a university, you have access to this advanced option that I'm showing you right now. Click hierarchical Bayes, and when you run the analysis, JMP will use estimation that allows subject level parameter estimates. So you can see because we've used a different estimation method, the utility values that we've estimated differ here. But you also have a new red triangle option, save subject estimates. So when I click on that, I have marginal utility estimates by subject. So here's a line for each of the 30 respondents in this survey. So here's all of the subject level estimates for the all dressed flavor or for the barbecue flavor. So here's some high utility estimates for the barbecue flavor. These people probably like it a lot. Here are low estimates. These people don't appear to like it all that much. This table comes with a script you can run next to hierarchical clustering that automatically performs hierarchical clustering. And you can just go straight to the cluster summary to get information about the clusters that are uncovered. So it found 3 clusters. And here we can see what drives differences between them. And a big one right here is preferences for ketchup, where members of cluster 2 actually seem to favor it a little bit, but clusters 1 and 3 do not. If we want, what we can do is save these clusters back to that subject level estimates table. So here's that table with now the cluster information saved to it. And when I click merge data back, that has now been added to our original data table. So every single subject here has some additional columns with their individual estimates, and most importantly, the cluster or market segment that they belong to. So if we go back now to MaxDiff, what we could do, and for the sake of time I won't, is we could add cluster as a subject side effect, or we could declare it as a by variable to just run completely separate analyses for each market segment that we've identified. Now, everything I just showed you here, this is more advanced, right? I mean, I think maybe in a more introductory and applied undergrad course, perhaps this might be a little beyond what your students are doing, but certainly if you're teaching this at a master's or even PhD level, you're probably going there. So I just wanted to make you aware of this one potential way of doing market segmentation in the context of a MaxDiff study. So I've been chatting for a little while, getting hoarse, going to have to take a sip of water, so it's probably a good time to pause and take a look at the Q&A. Volker, do we have any outstanding questions that we should answer before we move on?
Ross, a few have been answered. There was one question about clustering. Can latent class clustering be used instead of hierarchical clustering?
Yeah, so you can perform clustering and derive these cluster values using any of JMP's tools. In this case, we had the subject level estimates as the basis for the clustering, and you wouldn't use latent class for that because that clusters categorical variables. But in another context where you have, let's say, demographic information that consists of categorical variables, you could just cluster based on demographics, let's say using latent class, and then apply those clusters to your MaxDiff analysis. But that said, again, the bigger point is when you output that table that I showed you, it comes with a hierarchical clustering script. But in general, if you know clustering and you want to use another clustering tool to derive market segments, go right ahead.
Thank you, Ross.
Are there any others?
You're good to proceed.
Wonderful, thank you. Okay, so let's move on to the last topic for today, discrete choice. And you're going to find that a decent amount of what we've already covered applies here as well, and that might not surprise you given that MaxDiff is really just a special case of a discrete choice analysis. So let's take a look, as usual, at the example that we're going to do. This is on the pricing of eyeglasses or spectacles. Here's the data. Here's just an example of data from one respondent. So in this particular study, we present product profiles consisting of multiple attributes, and folks just make the choice about the profile that they prefer. You'll notice here, if we look at the choice set numbers, choice sets are just of size 2 here. So here's the choice set 1 for respondent 1. Now we have different attributes of eyeglasses or spectacles, like the material that they're made of, the shape, the color, their weight, the type, so full frame versus half frame. And then the price, $475 versus $725 here. So we can see, again, if we look at respondent 1, and we look at choice sets, they responded to 10 total choice sets. And in the response indicator column, there's just a 1 for the member of the choice set that they preferred. This one comes from the JMP case study library. You'll actually find it immediately beneath the pricing musical instrument case study. This is the pricing spectacles case study. For the sake of time, I won't take you into the PDF, but just like we saw with pricing musical instrument, there's a full walkthrough of the design and analysis related to this, along with some exercises for students to do on their own. So as we've done with the other two, let's look at how to design this study and then talk about how to analyze it with a couple thoughts on teaching along the way. So to analyze a discrete choice experiment, we're going to go to our consumer studies and choice design. Unlike MaxDiff, it's not looking for a table of profiles or attributes along the way, but we can use one. So here I have an attribute table. Instead of specifying them manually, which I could do by adding factors of different levels, I'm going to use this attributes table, go to the red triangle, and go to load factors just to load them in. So to reiterate then, looking at our factor table here, we have 6 different attributes, 3 levels of material, 3 levels of shape, 3 of color, 3 of weight, 2 of type, and 2 of price. I'll click continue. Let's minimize a couple things and focus on the types of designs being made here and what options you have. First, you will notice if you go to the DOE model controls that by default, we are assuming a main effects model here. So that is no interaction between any of our product attributes. Again, if this is the first time you're exposing students to this or they don't have strong statistical background, that's probably where we're going to leave it. But in a more advanced course, you might introduce two-way interactions, and you can do that just by clicking the interactions button. The window just got a little bigger right there because there's a much larger table under the prior specification under it, so I'll just collapse that. So now you can see we would create a design here that assumes all of the 2-factor interactions, or I could even just select a subset if I only want a subset of them and click remove term for the ones that I don't want. In this case, I'm actually going to remove, all the ones that I don't want to get back to just that main effects design here. JMP's choice design platform uses Bayesian d-optimal designs. It's certainly beyond the scope of what we can do right now to explain them. Again, in a more introductory course, perhaps you don't want to go to Bayesian d-optimal designs and explain why they're necessary here when we're assuming a nonlinear model. So you might instead choose to just tick the boxes to ignore the priors on the mean and the variance covariance matrix here. So by default, you could just tell your students, don't worry about it, tick those, and JMP will still compute a design for you. Just know that they're there. So if this is a more advanced course and you want to set priors, this is where you would do that in these tables right here. So I'm going to leave that as is. And now just get down to the final element of the design, setting the number of attributes, choice set size, and so forth. So these are all pretty self-explanatory right here. You can set, for example, the number of profiles per choice set right here, the number of choice sets per survey. If you don't include enough profiles per choice set or choice sets in the survey, JMP will give you an error message telling you to increase them. The one thing I do want to point out here is that, it's relatively common, especially if you have a large number of attributes, to use partial profile designs where not every attribute changes within each choice set. So by default, this number of attributes that can change within a choice set is set to the number of attributes we have, 6. But if you want to do a partial profile design, you can reduce it to, say, 4 if you want 2 attributes to be held constant within each choice set presented. In the particular case study we have, we're going to allow all to vary, just 2 choices per choice set, 10 sets per survey. We're just going to build one survey that we could build multiple, and we anticipate having 100 respondents. So I'll click Make Design. Here is the design. And I can now choose to output separate tables if I want to pursue a multi-table format in the analysis, or just go into one table, which I recommend for that single table format that we saw previously. So here's our output table right here, all of our choice profiles. We can fill in our response indicators and then use the embedded script to perform the analysis. So let's actually do that now. Let's perform the analysis. So I'm going to open up that data table. This is the same design, but now we just have the 1s and 0s filled in as before, and I'm not going to go over it again. Note that we have that single table, multi-table format supported. Also note that when you go to consumer research and choice, you can specify whether there is a none or no choice option if you have a design that allows for that. We don't here, so I'm going to not tick that box. And we fill out this dialog as we did before. So here we have our response indicator. We have our subject ID, our choice set ID, Now we have 6 profile effects. I'll just do the main effects here. I won't do the subject level estimates with hierarchical Bayes right here. I will instead just click Run Model to get to the report. So here we have statistical tests. We also have the parameter estimates right here. So again, these are the part worth values. This doesn't correspond quite like we're used to seeing in the MaxDiff platform. And if you teach choice, you're probably teaching MaxDiff. So know that you can go to the effect marginals option under the red triangle to get an output that corresponds more closely to what you'll see in the MaxDiff platform. So here's effect marginals. So we have our marginal probabilities and marginal utilities. For example, thermoplastic has the highest utility for material, lowest is steel. It looks like the rectangle is the highest utility for shape, and so forth. Now to calculate profile utilities, head on over to the red triangle and select the utility profiler, which you're going to find right here. So this, if I make it just a little bigger, allows me to specify any product profile and calculate the utility over here on the left. So for example, if I wanted to see the minimum utility, I can specify it here and see that the utility is negative 3.34 approximately, and that's for steel, aviator, golden, and so forth. Of course, we saw the output grid table option. That's again available here. And there's some other some other profilers as well, like the probability profiler or the multiple choice profiler. Let me just show you one. In the multiple choice profiler, we can specify a number of different profiles. I'll stick with 3 here and see the relative selection probabilities or market shares for these 3 profiles. So you can see right now I've specified the same default or baseline profile for each of the 3 here. And the relative share or selection probability is equal, 1/3 apiece. But now let's say that instead of them being the same, I'm going to vary the material. So alternative 2 will be the acetate and alternative 3 will be steel. And now I can see that the first profile is preferred with a share of 0.49 approximately, the second 0.36, and the third 0.16. So you can look at the relative profiles across any, or probabilities, across any number of profiles using this multiple choice profiler. I'll leave it to you to explore the probability profiler on your own time. The last thing I want to highlight is here with choice models, you also can calculate the willingness to pay. So that is how much somebody's willing to pay for a marginal change in one of or more of the attribute levels. To do that, you first need to change your price factor to continuous. So go back to your data table, change it to continuous. And then under the red triangle, you're actually going to find the ability to just redo the analysis. So let's take a look at this one. So everything looks the same that we just did, but I can now go to willingness to pay. And without getting too deep into the details, I think if you explore this on your own, it should be readily apparent what we're doing here. But we're going to specify a baseline product. I'm going to specify the baseline as a pair of steel glasses, which was the least preferred. I'm going to hold constant all of these other factors or attributes, and then ask, what is the amount that somebody's willing to pay for a change in material? So here, if we were to upgrade to thermoplastic from steel, somebody would be willing to pay, we predict, about $255 for that. Versus acetate, they'd be willing to pay only $185 for that upgrade. And the new price that we might be able to charge is estimated right here. So don't miss that willingness to pay option right here. And just remember that if you want to use it, you need to change price to a continuous variable, and JMP will prompt you to do that if you don't do it already. Now, just for your own notes, I've highlighted here that you have options for market segmentation as well. Much like you did in MaxDiff, you can click here to learn more about the different options and see examples. But with that, we have just a few minutes left. So let's talk briefly about the different teaching resources available to you if you're teaching consumer research methods, and in particular, the methods that we've covered today. So when you get this journal, have a look at the teaching resources section. At the top, I'm listing this textbook, Market Data Analysis Using JMP, by Walter Pachkowski. This is actually a book that I used to learn some of these methods and their JMP implementations. This is a pretty strong non-technical or applied book for teaching conjoint, MaxDiff, choice, as we've seen today. Also, elements of survey analysis that include, cross tabulations, basic regression, things like that. Also, market segmentation. It includes sample data sets and case studies that you can draw on for your course. It includes instructions for performing the analyses in JMP. You could use this as the basis for a highly applied course, or maybe as a sent to a course that is a little more on the mathematics. So go ahead and click on these links if you're curious to find versions digital on Red Shelf or print on Amazon. I've also provided links again to the 2 case studies that we looked at in the JMP case study library, and then references to some example data sets that you can always access under Help Sample Index. We saw the potato chip example. That was our MaxDiff example, but there's also one on pizza for discrete choice studies that we didn't look at. So if you go to find pizza combined in the sample index, that's a single table format for a discrete choice analysis. There are also separate tables if you want to do the multi-table format, but they're all the same example. In this case, discrete choice related to different pizza profiles.